workshop. Hopefully everybody got a chance to have their lunch. Um, Dr. Sam Callisto will be give us a tutorial on the R workshop. He currently works as a senior scientist at Metrum in the modeling and simulation group. He has expertise in applying pharmacometric approaches to answering questions throughout drug development and has contributed to development of open source software tools aimed at simplifying analysis for pharmacometricians. He earned his PhD in experimental and clinical pharmacology from University of Minnesota College of Pharmacy, where he also served as the adjunct assistant professor. Please help me welcome Dr. Callisto.
Thank you. Hi, everyone. I'm sure you are all very excited for the R workshop that people have been hinting to the past few days. So we finally made it. I had an ambitious schedule set up for us, and there seems to be a bit of a delay between what I'm sharing and what I'm seeing. Oh, okay. Okay, cool. Well, we'll work with the delay. So we're starting about 10 minutes late. We'll see how quick we go through the first one. We'll shift this as needed, but it's broken down into 4 parts. I'm going to lecture for a bit. We're going to do some hands-on work. I have some TAs here with me. You all know Mike Heathman, and also Rena is here from Metrum as well. Not in the room at the moment, but she will be. So we will, during the hands-on, really circulate and help you figure out how to do these problems that I've given you. I sent out this slide deck as well a few minutes ago. So if you want to look through it while you're doing the hands-on, if you want to take notes while I'm giving the lecture, it's in your email. If it's not in your email, let Mike know. I'm busy talking right now. Great. So target audience, what are we going to talk about today? We're really aiming today to look at users with little or no programming experience. You know, maybe you are currently doing your data cleaning and building your data sets using Excel. I really want you to leave today feeling empowered to not do this in Excel. I want you to do it in R in a reproducible way. And I'm hoping that I'm providing you guys with the tools to do this yourself. And if you can't figure out how to do it yourself, at least how to Google the problem and find a solution on Stack Overflow that you can copy paste into your code, okay? If you maybe know some R, might be a good refresher. If you haven't worked with it in a while, I think it's really hard with these types of workshops. If you learn all this material, you feel really great, and then you don't touch it for 6 months. You're not going to cement anything that's learned. So I think if you have data, really try and apply some of these skills that we're learning today to your data sets. Think about, how could I put together a plot? How could I maybe do a simulation from my data set or something? I think there's a lot of material here that you can use and apply in your own research. There are some advanced topics that we're not going to touch today. I will give some resources for this stuff at the end that we have publicly available on Metrum's website. But really, it's going to be pretty basic stuff in the best way, though. Sometimes it's good to just go through the basics and have a solid foundation to build upon. Special thank you to Pete Bonet and Devin Pastor, who have presented versions of this material in the past and really helped me put these together. And also to Mike, who really helped me put this slide deck together as well. Okay, so we're going to start with base R. So R is a programming language. And why is R hard to learn? Because it's a programming language. A lot of people don't think of it that way. They think of it as a statistical tool similar to SAS, SPSS, Excel. It's fundamentally different from those. You need to think about R in a different way. You are building programs that are run from top to bottom. And the reason it's hard is because you have to learn this new syntax and you have to think about this as a programming language instead of just a tool to do some of your analyses. And it's really its greatest strength, but also it's a large impediment for new learners because it's learning the syntax and thinking about data analysis this way is challenging. If you haven't encountered programming before, and a lot of people, when they go into their graduate programs, haven't done any sort of computer programming classes in the past, and that's okay. You can learn this stuff, but that's one of the reasons why I think people really say, oh, I don't like R, it's too hard. I would rather use SAS or Excel, whatever, because you're learning a new language, and that's hard to do. But I'm going to hopefully give you some basic programming skills today that will help you learn how R works and how you can use it, and give you some reason why you would want to use R. So hopefully that's helpful. So a little bit about R. It's a programming language. It was developed in 1993 at the University of Auckland. It's based on the S programming language, which was developed by Bell Labs, which was a paid product. And this R is a free and open source alternative to that. And it has really flourished because of the fact that it is free and open source. What does open source mean? That means the source code is available. You can download it. You can make changes to it. You can take your changes and give it to someone else. They don't care what you do with it. And so open source is one of the pillars at Metrum. We really believe in the power of open source software. If you're building a tool and you want people to use it, letting them dig into the nuts and bolts can be helpful. I know not all of the tools are that way, but it's one of the philosophies that we really espouse at Metrum. So a lot of you were at the Quarto tutorial yesterday, so maybe you did see the RStudio and how Mutaz and Emma were interacting with R. And so many people do choose to use RStudio. It's a integrated development environment, or an IDE, that allows you to have a graphic interface with R and use it in a more easy way that allows you to look into documentation easily, or the files that you're inputting, outputting more easily. It's a nice way to really look at R, and so that's why we're going to be recommending that you use that when you are interacting with R, because it's going to make it easier to use R. There are two main types of programs that you can write in R. This is a bit of a generalization, but just simply there are R scripts, which are files that end in .r. And then there are also markdown scripts. And we can see, or we saw yesterday, the QMD files are the Quarto markdown files. There are also R markdown files. These are different in terms of how they structure the data, or sorry, how they structure the code. Markdown can generate some nice output files, which you don't get by default with R. And so I like to use R markdown files a lot because it organizes your code and allows you to separate chunks out. And I think that was shown really nicely by the presenters yesterday in the Quarto tutorial. But for either type, they're going to run the commands in your script in order from top to bottom, unless there's a comment symbol at the start of the line. That means that line will be skipped. So we'll see some examples of this throughout. Okay, so a couple basic concepts when you're working in R. We want to think about a working directory. When you're running a program in R, this is where it's going to start and look for any files that you're pointing to. There's also, in terms of how your different packages or libraries that you may have installed are related to the project, it is handled by projects in RStudio. So your working directory will be the starting point for your analyses that you're running in R. You can, from the command line, use these commands to set where your working directory will be. You can show where it is. You can change it, also using the RStudio IDE in the settings in the file menu. So projects are a way of really organizing your work. When I think of a project in RStudio, I think about a discrete analysis program. I'm trying to, when we use it at Metrum, we really think about it's one client, one project is contained in an R project, and then everything that you need is contained within that RStudio project, including all of your scripts, your markdowns, your data, everything you're inputting and outputting. Yeah, question? Sure. So the question was, is there any drawback for using R if you are going to submit it for use at a larger scale? Yeah. I think a lot of companies have embraced R. I think the regulatory bodies have embraced R. It being open source isn't necessarily a bad thing in terms of those things. I think I don't know. I want to speak for everyone everywhere, but like the FDA, the EMA, they all know and accept R as a valid tool to use in what we're doing. Yeah. Okay, so I'm not really going to talk about projects too much in RStudio, but you can, in RStudio IDE, file new project. It will create a little project folder for you, and it'll encapsulate everything that you want to do, and that's a nice way to use RStudio. But you don't need to do that. Okay, so now we're going to start having some code on the slides. I hope if you're feeling overwhelmed by this, that's okay. We're going to walk through it. We're going to learn together. So when we're creating and using variables in R, we are going to be using the assign operator. This is the less than hyphen. There's no space between them. It looks like a little arrow. So it will take what is on the right-hand side of the statement and store it in a variable name on the left-hand side. So in the code, we can see we're going to take the string hello world and store it into a variable called test. When we type test into the console, then it will print back hello world. We can look at the class of this, and it will say, I don't really have that shown here, but unlike other languages, R doesn't really require you to specify what type of data is going to go in that variable. So what I was trying to show in this code chunk is we're starting out, we're storing a character string in test, and then we're overwriting it with the number 11 as well, and that's not a problem. So even you can overwrite it, you can use different data types. It's not really strictly enforcing how you're using these variables. You can use them flexibly. So the other way that we are going to a lag, there we go. So the other way that we're going to be using R is through functions. And functions are an object which contains a series of instructions which are performed in a specific order. So when you have a function, it is always going to be the name of the function followed by parentheses. Inside the parentheses are then arguments which are used by that function. So you could say arguments are passed into the function. There's different types of arguments in functions. Some arguments will be required, others are optional. Some arguments will have defaults, and understanding what those defaults are in a function is going to be important when you're using it, because it's going to tell you what assumptions are being made in the function. If you're running linear regression, there's a bunch of defaults in there, and if it's not what you want it to be, but you're not aware of it, you're not going to get the results that you're looking for. So I'm going to show you how you can uncover those defaults as well as we're looking at this today. In base R, there's a lot of functions, but there's even more in R packages. So R packages can be installed and loaded and allow you to have a multitude of functions for various tasks that you're going to try to use R for your research. In RStudio, another reason why it's nice to use this IDE, you have quick access to the help files. You can do that you can access those files by using the help function, or there's a shortcut with just a question mark in front of the function name. If you type that into the console, it'll pop up the documentation and show you what how the function works, what the arguments are, what the defaults are. And you can easily define your own functions, and that's something that we're going to talk about at the end of the day today. This is a really powerful way to reduce your copy pasting in your code and consistently apply the same set of instructions consistently in multiple use cases. So R represents data in a couple different ways. So numeric types are numbers that have a decimal, and integers are number types that are whole numbers and do not have a decimal. That's not 100% true, but it's simple. It's a simplification that we're going to use for today. There's also logical, and these are represented as true or false in all caps. And this is used for conditional statements. Is 6 greater than 8? It would return false. There's also character, and this is how R represents string values. And it can be either a single word, a sentence, a paragraph. It is any character that you're going to have is stored as a character. And then the last type that we're going to be talking about today is factors. And this is a special type of character where you're able to enforce attributes such as level or order. And that's useful when you want to make stuff show up in a certain way in your plots, for example. So if you want to interrogate an object in R and know what the class is, then you can use the class function, and that's going to tell you what type an object is. So in this first chunk of code at the top, we have the value 12 stored in the variable x. We're going to look at the class of x, and it's going to return and tell us that it is a numeric function, or sorry, a numeric data type. You can also use specific tests that will tell you if it is a certain type. So on the bottom, we're going to ask, is x numeric? And it will return true. Is it a character? It will return false. So all of the data types that I mentioned have this type of is dot, and you can check. And you can use that in your code to apply functions only to numeric types or not to character types. So that's why they have this type of function built into R. So sometimes we may want to convert from one type to another. This is called typecast. Oh, was there a question? Yeah, great. Water break for me.
Hello. Yeah. So if you wanted to type a comment into R, is there a specific syntax you have to use, or is it?
Yeah, great question. So if you want a comment in R, you just need the hashtag character at the beginning of the line. So on this slide, I'm showing the output as commented out, as a commented out line. You can use a single hashtag, you can use 2 hashtags. As long as it starts, the very first character in a line is a hashtag. Everything after that will be ignored by R.
Okay. Thank you.
Yeah. Okay, so when we want to take one data type and convert it to another data type, this is called typecasting, and this is easily done in R. They have built-in functions that will do it for you. This first line, as.character, so we're inputting the number 1. It's not in quotes, it's numeric, but it's going to return a character value, and we can tell that it's a character value because it is in quotes now. Same with the next line, as.numeric. We're passing in quotes this value of 12, but then we're typecasting it using as.numeric, and it will return a numeric value. If you try and apply typecasting to something that cannot turn into a number, such as A, we can't turn that into a 1 automatically or something, it's going to return an NA. So NA is how R represents missing values. And it's important to know that NAs are contagious. So if you have an NA and then you do an operation on it, you're still going to get an NA out. So it's important when you're building your scripts, thinking about how can I check my outputs as I'm going through, and build it in a way that is going to prevent anything from happening where an NA shows up and goes downstream and then you're not going to get what you want. Yeah, question. No such thing as a dumb question.
If you were to like put the number 1, but like spell it out in the quotes and then have it put as numeric, would R be able to interpret that, or would it
No.
be like no?
It would not. Yeah. It really has to be, if it takes the quotation marks off, it needs to be able to understand it the same as you would type it into the console. But the other way is not true. If you can almost always convert to a character. It's going to just take it and put quotes around it. Okay, so now we're going to talk about data structures. So we know the data types. How are these different data types going to be stored in together? So you can think of a scalar, and this is an object that just contains a single value. So x, we're storing 12 again, and so it's a scalar value. It's just going to be the number 12. A vector is an object that contains a set of elements, but they all are of the same class. So here we see the syntax in R where you can get the values between 0 to 12 by putting a colon between those two values. And we're storing that in the variable y. When we enter y into the console, then it's going to print out all of those values, and we can see 0 to 12 are stored in y as a vector. They don't have to only be numeric. They can also be character. So I'm showing the names, 3 names stored in a vector with the variable name names. And we want to look at the second element of names. So we're using the square bracket after names and saying, show me the second object in names. And it's going to print out Ralph. If you are familiar with other programming languages, some programming languages start with 0 for the first element. That is not done in R. It starts at 1. Okay, so I mentioned the 0 to 12. There's a lot of different ways that you can create numeric vectors in R. So I'm just going to pop through a few of them. So 1:5. Who was listening? What is this going to show? You can shout out. Perfect. Thank you. Okay, now sequence. I won't make you guys guess. This is going to do the same thing. From 1 to 5 by 1, it's going to print those out. So this is an equivalent way of doing 1 to 5. Why is this useful? Because by doesn't have to be by 1. You can count by 2, by 10, whatever. So this is more flexible than the colon and is a really nice way. So that's the sequence function. Okay, now this is replicate. Does anybody want to guess what rep 1,5 is going to do? Repeat 1 5 times. Perfect. Yes, that's perfect. Yeah, so it's going to repeat. It's going to return a vector where 1 is contained in all 5 elements. Yeah, question.
So is the seek function, is that for storing data or for printing data after you've established the 1:5?
So it's a different way of doing 1:5.
Okay, got it.
Yep.
So this is how you would input that function.
Correct. Yep. And so great question. So this is not being stored in an object. This is just printing to the console. If we wanted to store it into a variable, we remember would have to use the assign operator and have some variable name that it's going to be stored in. So my vector, assign operator, sequence. Yeah. Another question back. Yes.
And for the sequence function, can by be a character? Can you designate like even or odd, or does it have to be numeric?
I think it has to be numeric. It would be tough to implement that. Yeah. But if you wanted it to be all evens, you just have to think about how to structure your, from 0 to 10 by 2. And then it's going to return all of those even values. Okay, now we have this C function, which just allows you to have a list put together. So we're just going to say we want to create a vector and in order store these values 4, 2, 3, 1, 5 and separated by commas for each of the different values. So when that prints, it's going to show us the vector now has 4, 2, 3, 1, 5 as they were entered. And now this is where it starts getting a little more flexible. So you can take that C operator, you can wrap it in a different function. So for example, sort, and what it will return then, it will sort the values in that vector and return them to you in ascending order. And so this is where you can take the output from one function and use it as input for another function, and this is called nesting. I'll also say this C operator doesn't have to be numeric. You can have characters as well created using that C operator. Okay, so factors, I mentioned they're enumerated character data type where you say what levels you would like, and then it will store those. So we can think of each of the labels that we're creating to correspond with a numeric value. So this first argument X is what the data that we want to add the labels to. So I'm giving it a series of ones and zeros. For the levels, I'm telling it what values there possibly could be in the X vector that I'm passing into it. So I'm saying 0 or 1 are the two options. And then I'm assigning labels in that same order. So I'm essentially saying for 0, convert it to female. For 1, convert it to male. And then we can see it prints out with the labels now what the values are according to the label. And then it tells you what possible labels there are in that factor. There are also matrices, which are commonly used when you want to start doing more math and statistics sort of things. You can have an array where there are multiple matrices stacked in n dimensions. And then there are lists. Lists are objects which contain other types of various data types. So up until this point, everything has been the same data type within that data structure. Lists are unique in that they will allow you to put anything in. So in our example code here, we have first colors, which are character strings. Next, we have evaluation, which are logical values. And we have times, which are a matrix of numeric values. We can access the contents of your list. So this object is being stored in the variable myList. When you print myList to the console, it will print out all of the different what would I call those? Parts, segments of the list, so that the colors values are all in the $sign and evaluation and time. You can also access those values directly by just putting the $sign after myList. And I have some examples of that later on as well. And a huge benefit here, you may or may not have noticed, the items do not need to be the same length. So you can stick them together. It doesn't matter how big or how small they are, but you're including them all into one object that then you can pass around easily and apply functions to. In contrast, data frames, yeah, question.
In the before slide.
Yeah.
Last one where the time section, the n row is the number of rows, right? That
Yep, for the matrix, that is an argument to the matrix function. So here we can see that first line matrix, so from 1 to 16, and build that matrix with 4 rows, and then it's going to fill them either by row or by column. And so you're passing the true value to by row, which means it'll fill your matrix by row.
I mean, it directly assumes the number of columns without specifying the number of columns.
I think if it's a...
Since we are just specifying the row.
Right. I think it has to be square. Has to be, yeah. So your row and your column value is identical. It has to be a square if it's a matrix.
Thank you.
Thank you. Yeah.
Sorry. Oh. I love list because you can put whatever you want there, but can you give us an example why this is super, super useful?
You know, how I use lists a lot
Yes.
are when I'm returning a value from a function. So this is maybe getting a little into the weeds for right now, but when you're returning from a function, it is easy to package everything in a list that can then be accessed down the line. You can also use lists when you're mapping, which I'm also going to talk about in the fourth lecture. They're beneficial for applying functions to in a way that is repeatable.
I mean, in my specific case, I use a lot this. When you have a script and at the very, very, very beginning, you want to specify everything that you want to be consistent along your script, like, for example, directories, characteristics for the figures, colors. So it's super, super useful.
Absolutely. Yeah, that's a great way to use it. Did Mutaz have a question as well? Please.
Sorry.
So usually list is really good when you are doing unbalanced simulations where you have, for example, 100 individuals, but each individual have different sample times.
Right.
So the list would be really good because it's unbalanced. So that would be good.
Yeah, that's a really great point. Data frames are going to require everything to be the same length, but lists will allow you to have different number of observations per subjects. Okay, so data frames. This is a two-dimensional object made up of rows and columns, but each column can be a different type, but it has to be the same number of rows. So this is another kind of similar to what was shown on the previous slide, but now we've truncated it to just show, to just include the 3 values rather than having multiple different values for each of the items. So when you create this data frame, you have the name that you want the column to be, and then you're using the equal. So a lot of times you want to use the assign operator. When you're within an argument, you're going to use the equal sign. Kind of a weird nuance to get used to, but that's the main difference. If you're assigning something to a variable, you want to use assign, otherwise you'll just use equal. So then on the right-hand side of the equal sign, we have the values that we're going to assign to that column. And then we print out my data to the console, then it shows us the row numbers first on the first column, and then we have the different columns by name. So dimensions will show you what the dimensions are of your data frame. You can access individual columns using this dollar operator. So that's the same as you can do in list as well. And you can access individual row, column, cell by using these square brackets and then using comma separation between row on the left and column on the right. So I'm saying, show me the second row. There's nothing after the comma, so show me every column. If I wanted to just see the value for evaluation in the second row, then I would do my data square bracket 2, 2, close square bracket. Here are some useful mathematical operations. These are just functions primarily. We also have the typical arithmetic operations at the top. So if you want to add, you can just use 1 plus 2. You don't you don't need to use a plus function. But it's important to realize that these functions will operate on both scalars and vectors. You don't need to do anything special if you want it to run on all of the items in a vector rather than if it's a scalar. So you can use these functions in either way. We'll talk about that a bit more later on as well. Last thing that I really want to talk about with this first lecture is reading and writing data. So there's a reader package. We're going to in the tidyverse libraries, and I'm going to talk about that a lot in the next lecture. But just so you know how you can read in data and write data, the most typical format that we're going to use is CSVs. So you just use these functions, read CSV, write CSV. You can see an example of the code on the bottom. So library is going to import an R package that has the additional functions. So we're importing reader, so then we can access all of the functions that are included in reader. We're going to use this read CSV, and then we're going to store that into the NM data object, and then we can look at the dimensions of the object. So that's how you would read in data. This is a this is a relative path from your working directory. So I mentioned earlier that your working directory is set, and that is where it's going to look for files. So in this example, I'm saying it is this exact file is in the working directory. If it's in a subfolder, then you would need to specify the folder / name. And so that's the relative path. There are also some base R functions that do the same thing. Read.csv, and there's other types of data structures that you can use to store your data on a disk. But I think these are probably the most important for people who are just starting out with R, and just save it as a CSV. Here is Mike's unofficial style guide. I'm running a bit behind, so we're going to just skip over this. You guys can look at it, and some tips on how to make your code look clean. But you don't need to follow it. These are all optional. Okay, so I want to do a quick demo of RStudio in case people have not used it before. So let me find my R session. It is on the other screen, so I have to somehow drag it over here. There it is. Okay. And we go. I'll go back to computer on that one for everyone and reshare my screen. I think we can see it. Okay, great. So just want to give you an introduction to RStudio, because now we're going to dive in and start using it. So there's two ways that you can interact with RStudio. We have down here is the console. So this is not going to save your code. It's just if you want to do something and have it printed, you'll do it in the console. If you want to write an R script and then run it, we're going to create a new R script. At the top here, there's this little icon, and then create a new R script. We're going to do that. You can also do file, new file, R script, and then there's a bunch of other types of files that are supported by RStudio, but today we're just going to be looking at R scripts. So then if you want to do something in your R script, you type it. So I want to store the value of 12. I want to look at the class of X. So we can save it to disk, just how you normally would, file save. And then when you want to run the code that's here, it's not automatically going to be run when you write it in the R script. There, on Apple, it's Command Enter. On Windows, it's Control Enter. We'll just run the line that your cursor is on and move you to the next line. So I ran that line of code. We have 12 stored in X. I want to see the class of X, and it will print to the console the results of that function. You can also see this X object has been created and now is shown in the right in this environment window. And so this is a nice way to easily see quickly what do you have loaded into your environment. If you have any objects that you've stored, they will be up in that part of the screen. Okay. Now, need to reshare the other display. I should have done this a little differently. Apologies for the. Okay. I think I'll have the space. Let's talk in 2 minutes. Yeah, okay, so we're gonna do a hands-on now. So I have allotted 15 minutes for this. We're a little over time, but we have a lot of time at the end. So yeah, let's say from now until 1:05 Eastern time for people online. Here's what I want you to do. I want you to create the data frame that is shown in the table on the right. I want you to save it to an object called dat in your session. I want you to verify that it is a data frame. And then I want you to save it to disk as a CSV in your working directory with the name output.csv. So begin, raise your hand if you need help. We'll be kind of circulating to answer any questions that come up. Okay, so slight change. At 1 o'clock, I'm going to go through the answers. So you have 8 minutes to kind of figure it out by yourself. And then you can either ignore me when I start going through it if you want to finish it. But I'm going to just kind of try and keep us on schedule as much as possible. We have a question online. What is the difference between ... and ... Oh, single quote versus double quote. You can pretty much use the single quote and double quotes interchangeably in R. Good question. Okay, so I'm going to run through how I did it. And I would like to emphasize at this point, there's no one single correct way to do anything in R. If you did it in a different way, it's not wrong. And that's just a nice thing about R. Okay, so here is my solution. So I am actually creating an object called n_id, number of IDs, and I'm storing the value of 3 in it because I know there's 3 IDs in the table, and I'm going to use that value multiple times while I'm creating it, so I thought I'll store it so that I can reuse it easily. I'm going to create the data frame. I'm going to assign the values to the variable name on the left-hand side, dat, and then we're going to have a list of the columns that we want to include with the name on the left-hand side of the equal sign and the values on the right-hand side. So for the ID, I'm going to use the repeat function. I'm going to take the values from 1 to NID, which equals 3. So that's going to give us 1, 2, 3. And I want that repeated 3 times. That's the second argument to the repeat function. So that's going to give us 1, 2, 3, 1, 2, 3, 1, 2, 3. I do not want them in that order, though, because the table was 1, 1, 1, 2, 2, 2, 3, 3, 3. So I'm going to use the sort function and wrap it around the output from the repeat. And if you recall from the slides, this will put them in ascending order. So then it will be assigning to ID the value 1, 1, 1, 2, 2, 2, 3, 3, 3. You may have noticed that the time column was the same 3 values for all 3 subjects. So I'm going to create a vector 1, 6, 24 using that C function. And I'm going to repeat that vector the number of times that there are IDs. So this is going to return 1, 6, 2, 24, 1, 6, 24, 1, 6, 24. For DV, there was also a pattern there that you could use the sequence. So it was 2, 4, 6. So you could type in C246, or if you saw the pattern, you could just say, I want sequence from 2 to 6 by 2. That'll give us 2, 4, 6. We're going to repeat it 3 times again. Now sex, we are going to kind of swap these operators. So we've been doing C on the outside, or sorry, C on the inside, repeat on the outside, and now we're going to swap it. So we're going to create a vector where the first 3 elements are M repeated 3 times, the next 3 elements are F repeated 3 times, the next 3 elements are M repeated 3 times again. And then weight is not, there was no pattern. So just, you can type it in and using the C function. And then there was a row column, and I just want to sequence from 1 to 9. If you look at the help for sequence, the default value for by is 1, so I don't need to say by 1. It will just return the values from 1 to 9. Question? I'm sorry, I can't hear you well. Is the microphone somewhere around?
So what's the idea to create a data object like number of ID it's equal to 3? So
it's kind of a way to prevent typos for me.
okay.
If you're taking the same value and using it multiple times, I'm just going to store it there and use it And then if I change my mind later on and I want to add an additional ID, all I have to do is change the NID, and I don't have to go through and read every function where I manually typed in the number 3. Yeah. Then I also asked you to verify the structure of your data. So if you type dat in, it will just print the data frame to the console. You can use the class function. It will tell you that it's a data frame. You can use the structure function, and this will show you the structure of the data frame. It's a slightly different way of looking at it, but it will tell you what data type is in each column, and then the elements within it. And then writing to file, we're using that write_CSV. The first argument is the object that you've created that you want to save to disk. The right-hand side is where you're going to save it. So we're saving it to our working directory, and we're naming it output.csv. Any questions about this before we move on? Great. Okay, so that was all base R functionality. You don't need to.
Just
Oh,
a
sorry. Yep,
quick
go
question,
ahead.
Sorry. Could you go back to the
Yeah.
previous slide? Yeah. Could you? I'm not sure if I missed this. Could you repeat why the n underscore ID is used instead of just like the?
So you could easily use the number 3. You don't need to save it. That's just a way that I wanted, because I knew that I'm going to use the number of IDs multiple times when I'm, how many times I want to repeat something, or I'm going to use it multiple times while I'm building the data set. So rather than typing it in every single time, I saved it as a variable that I could then use as an argument to the function when I'm creating it. And then in the future, if I wanted to make a larger data set, all I would need to do is change that NID value, and I wouldn't have to go through and figure out, which of these 3 corresponds to the number of IDs, which corresponds to the number of rows per ID. So that was why I did it. You don't have to do that, though. Yeah. Okay. So all of the stuff that we've done so far, except for the read CSV function, has been using base R functionality. A really nice part of R is it has all of these libraries that import additional functionality into R for you. And the largest and probably most commonly used is the tidyverse. And so the tidyverse is a bunch of different libraries that have functionality built for data analysis. We're going to go through some of the useful functionality that using the tidyverse will allow you to then apply to your research. So there's a bunch of different libraries. So I've listed the different libraries on the left-hand side of this table, and then kind of what they do on the right-hand side. If you want to install a library or an R package into your R environment, you use this install.packages, and then you have the name of the package in quotes. Tidyverse is kind of a unique one because it actually has a bunch of different R packages that when you type that in, it's going to install all of the tidyverse packages for you. Then when you are in your R script and you want to use one of the functions which comes from those packages, you do that by loading it into your environment using this library function. So when you type library parentheses tidyverse, it's going to load in all of the tidyverse packages for you. So when you start your next hands-on, remember to put library tidyverse at the top so that you load all those functions in. Okay, what's a tibble? So we talked about all these different data structures. A tibble is a special type of data frame that's used by tidyverse. It will include additional information about your columns and the data frame itself. When you're running tidyverse functions on a data frame, it's automatically going to return a tibble, but you can treat the two the same. If you need to, for some reason, convert, you can just use the typecasting functions to convert between tibble and data frame. We also have the pipe function, so the pipe operator. And this is represented by percentage greater than percentage. If you're on Mac, you can use the Command Shift M as in Mary, and that will insert the pipe for you. Or if you are on Windows, I think it's Control Shift M. If I'm wrong, somebody tell me. So what the pipe operator does, it passes the output from the left-hand side of the operator into as the first argument of the function on the right-hand side. Yeah, that's confusing. So this is equivalent to mean parentheses 1:5 end parentheses. And I'll show a lot of examples of this, but when I was showing you kind of these nested sort, replicate, all that, you can use pipe, and it's a way of nesting, but it's going to make it more readable from left to right. You're going to take what is the output on the left-hand side and use it as the first argument in the function on the right-hand side. There is also a new pipe that is native to R. They are mostly the same. I don't really use it because I like the keyboard shortcut. And that's really the main reason I don't use it. But you can use it if you would like to. Okay, so we're going to talk about data manipulation verbs. And these are really what you're going to be using on your data frames and the data sets when you're doing your analysis to build them, modify them. So the 5 main ones that I'm going to talk about first are filter, summarize, mutate, select, and arrange. And I will go through these in order one by one. So first, we're going to start with a data frame similar to the one that we just made. So we're going to have IDs from 1 to 5. We're going to have a gender assigned to each of these IDs and a weight assigned to each of these IDs. So filter is going to keep matching row criteria. What does that mean? So we're going to take our data frame on the left that we just created, is the first argument to filter. The second argument is a conditional statement. So we want all of the rows where the gender is equal to female. When you're doing a comparison, you will use equals equals. So that's why it's equals equals there. So what this function returns is the data set, all of the columns are there, only the rows where gender equals female are retained. For doing comparisons, there's a lot of operators that you can use. Equal to, not equal to, so the exclamation point is not in R. So you can see exclamation point equals is not equal to. Greater than equal to, we have our NAs, we have our not NA. There's a duplicated function, which if you want to have, remove any duplicated rows, it will do that. And then I'll kind of talk about that as we're going through next. And then the last thing is on this right-hand side there's ands and ors. I want to do this and that. I want to do this or that. This is how those are represented. I'll show examples of that in the next couple slides. The pipe operator, the pipe, the up down is or, and then the ampersand or the comma is and. Okay, so now this in. We're going to say filter the data frame. We want the IDs that are in this character vector. So we're saying 1, 3, and 5 are what we want to keep. So it's going to go through, find the IDs equal to either 1, 3, or 5, and then it will return that right-hand side just the data frame with those rows retained. So we're dropping 2 and 4 because they are not in our vector 1, 3, 5. Now we're going to look at the and, so we're combining stuff now. So we want to only keep rows where the gender is male and the weight is greater than 70. So there are 3 rows where they're male, but only one of those rows also has a weight that's greater than 70. So we're linking these together with this comma inside the filter call. Now, that's opposite from how the OR operator would work. Here we want to retain all of the rows where gender is equal to female, or weight is less than 70. So it's going to retain row 3 and 5 because those are female, but it's also going to retain row 4 because the weight is less than 70. Okay. Any questions on the filtering and building these equals, not equals in? Not yet. Okay, they'll come. So now the next verb that we're going to look at is summarize. So this is going to calculate a summary and return a reduced output, a smaller version of the table. So again, we have our data frame on the left-hand side. We're going to use the summarize function. We want a new column named mean weight that will be equal to the mean weight of all of the weight values that are currently in there. So it's going to take from row 1 to row 5. It's going to calculate the mean, and then it will return just a data frame with the single column mean weight and a single row, which is the mean of all 5 of those. You will notice here that I'm using the pipe operator again. And this is equivalent to what is on the bottom here. The data frame is the first argument, and then it is being passed from the left-hand side into the first argument. So these two calls are equivalent. If it's still not clear how the pipe operator is working, please let me know. We can talk about it more in depth. But I'm going to just start using the pipe operator a lot more so you can kind of understand how these things are building and being passed from left to right. So this output is maybe not how we want to look at our mean weight. Maybe we want to think about between males and females, there's going to be a different mean weight. How would we calculate that? So this is where the group by function is introduced. So we're going to have a pipeline now, is what we're calling all of these sequential function calls that are separated by a pipe. And we're going to take the output on the left and put it into the first argument on the right. So we're going to take the data frame, pass it into group by, and we're going to group by gender. So it's going to look for a column named gender. It's going to take the operations that are next given and apply it to each of those subsets. So it's going to take all of the rows where gender equals male, calculate the mean. It's going to take all of the rows where gender equals female, calculate a separate mean. It's going to output then, on the right-hand side, we have gender retained as a column because it was a grouping variable. And we have the mean that is output from this summarize function as the next column for each of the male and female values. At the end of the summarize, we're calling this ungroup function. And you can think of grouping as like setting, you want to do it for a certain number of lines, but then you want to turn it off and you want to go back to like doing applying functions to the whole data frame. And so that's what this ungroup does, is kind of turns off that group by. So anything between group by and ungroup will be applied to those groups only. So you should always ungroup after you're grouping. It's good practice to do so that you don't carry grouping later on and apply like a linear regression across groups on accident. That would be bad. So I'm not going to include it in every single slide, but just kind of remember, if there's a group by, there will be an ungroup afterwards to remove that grouping variable. So then with summarize, we can have it create multiple columns for us. So we're going to do this mean weight again. And then we also are going to use this n operator, the number of rows that went into that. So we can see there were 3 males, they had a mean weight of 70, 2 females, mean weight of 64. Okay, so that was summarize and group by. Now we want to look at mutate. So summarize is going to take your data frame, apply some function, and return a subset. Mutate is just going to add additional variables on, additional columns to the end of your data frame. So how's that look? So if we were to mutate instead of summarize here, it's going to retain the 3 columns, and then it's going to create a new column on the very end, and it's going to have the value repeated for every row. If we do the grouping again, it will repeat for the males what the value, the summary value is for the males, separate from the summary value for the females. With this also, you can have multiple columns created within the same mutate call. So we want a mean weight. We also want mean weight and LBs. And that's how we're just separating it by commas. And it's going to stick it onto the end of the data frame in the order in which you are creating them in that mutate call. Time for some interaction from the crowd. We're going to use the mutate. We're going to use if else. So the first argument here, gender equals male. Second argument is a 1. Third argument is a 0. Would anyone like to guess what the new column ISM, what those values will be based on this call? Yeah. You are absolutely correct. I don't have, I need a more dramatic reveal. Here we go. Ta-da. Yeah, so the male subjects will have a 1, the female subjects have a 0 based on this. So how does that work? We're going to talk about conditional statements. So there's several ways that you can conditionally apply a function or return a value based on these conditional statements. The most common one that you're going to use in data analysis is if else. They also have other ways to do this. You can look in the backups for some examples of those. But how this works, the function is named if underscore else. The first argument is a conditional statement. And then the next argument is the value that is returned if it's true. And the third argument is the value that will be returned if it is false. And one thing to note, you want to make sure the values that you're returning are the same data type. It's not going to like if you return a 1 if it's true and the letter F if it's false. You got to make sure that the data types that you're returning are consistent within the column, because this is creating a new column. So when you're building these if-else statements, think about how to do that. And again, NA is how R treats missing functions, so you can put NAs in there as well if you just want it to be missing. We'll talk about that more during the hands-on if people are curious about it. Okay. So the next function now is select. So this is a way, we have a big data frame. Maybe we don't want every column. So select is going to allow you to grab specific columns. So here we're going to say data frame, pipe it into select, and we want to keep the columns ID and weight. So what's returned on the right-hand side is just the columns. The length has not changed, but the width has changed. We're only keeping the rows that are listed there in the function call. You can use the colon operator here to capture everything from one column to another column. So we want to keep everything between gender and mean weight. And so we can see on the right-hand side, that is what is returned when we do this call. Equivalently, you can use the minus operator in select to drop a column. So if you put in minus ID, it's going to drop the ID column and return everything else that was in the data frame. You can also rename while you're using this select operator, and this is going to keep ID and the weight column WT, but then it's going to rename it in the output weight. So it's new name equals old name is the order here for that equal sign. There's also a rename function that you can use, but this is different from select because it's going to retain all of the columns. It's just going to rename a specific column and keep everything else the same. There are a lot of ways that you can select using conditional statements. Here's some examples. I'm not going to go through all of these, but you don't have to type out every single possible iteration of occasion 1, 2, 3, and 4. You can use building these functions to not have to manually type out stuff all the time. The last main verb to talk about is the arrange, and this will reorder the rows. So if we want to arrange by weight, again, it's going to have the same number of rows and columns from the input. It's just going to rearrange the rows in the order that is given. So we're saying arrange by weight. So it will put them in ascending order now, the entire row. You can also put descending arrange. So if you want it to be descending, you can use the descending function in there. And now we have from highest weight to lowest weight. In addition to these, we have some minor verbs that I'm just going to kind of bop through kind of quickly. Distinct, slice, we already talked about rename and relocate. So distinct is going to reduce the number of rows and columns for your data set. So right here I'm using the Theophylline data set that's built into R just to show it's a really long data set. And I'm just showing the first 6 rows here. But if we use the distinct function, say subject, it's going to return the list of the subjects, the distinct subjects. And I realize that it's not starting with 1 there, and that's my error. It should 1, 2, 3, 4, 5, all the way up to the number of subjects. Okay, you can also, if you want to retain all of the columns, there is a keep underscore all argument to distinct, which defaults to false. But if you set it to true, it's going to keep all of your columns, and it's going to just take the first row for each one. So you can see 1, 2, 3, 4, 5. We now have 1 row per subject after calling distinct. There's also a slice operator. So we're going to group by our subject, and we want to keep the first and second row for each subject. So we're going to slice the first and second. And so you can see what's returned down here. This is an old version of these slides. That's okay, we'll keep going. The first and second row are returned, and then on the right-hand side, we are slicing, and we want to keep the first and the last. So the N is the size of it. So it's going to return the first and last row for each subject individually. You can rename. We showed how that works. You can change the name from subject to ID. And there's also a relocate function. And so relocate will move a column from one part of the data frame to the other. So our input on the left-hand side, we can see weight is next to subject at the beginning. If we want to move it, you can use relocate and say put it after the concentration column. So that's how you use relocate to move columns around in your data set so they're in a specific order. Okay, so there are some joins now that I'm going to talk about, and these are ways of taking 2 data frames and combining them together to get a single data frame. So the syntax is going to be join function, X data frame on the left, Y data frame on the right. Okay, so we're going to create 2 data frames here to work with. They each have 2 columns. They share the column ID. The left-hand side has times, the right-hand side has weights for each of these IDs. We don't have the same IDs shared between the left and right. So these are the joins I'm going to go through. You can read through this if you want, but these are different types of joins that I'm talking about. But I think it's easier to learn more visually. Okay, so these are represented colored. If it's in the ID time data frame, it's in blue. If it's in the ID weight data frame, it's red. If it's shared, it's purple. Okay, so we're doing an inner join, and order does matter here. So we want ID time and ID weight. So we want everything that is in ID weight and ID time that match to be kept. Anything that is not matching is discarded. So subject 3 in ID time is not kept because it's not in both, as well as subject 4 in ID weight is not retained because it's not in both. So that's an inner join. It's looking what's shared between the two. In comparison, we have a left join and order. So I said order matters, not really here. The columns order changes here. That's the only thing. But with left join, it's actually the rows that are going to be kept are dependent on the order. So with a left join, you want to take what's on the left, match it with anything that's on the right and bring it in, but then do not add anything from the right that's not in the left. So you can see that left join ID time, comma ID weight. We're going to keep 1 and 2 because those are shared. We're also going to keep 3 because it is on the left-hand side of the call. We do not have a weight for that subject because that subject is not in the ID weight data set. So it's just going to fill it with a missing value, an NA. You can see the opposite order here. At the end, we have ID weight, comma ID time. And now it's going to keep everything that's in ID weight and add on any times that are matched with IDs that are in ID time as well. And since 4, ID equals 4 is not included in the ID time data frame, we're going to put a missing value there, NA. Finally, we have the full join, and this is going to stick everything together and keep everything. So the output looks similar. The columns are swapped because it's going to put the columns in the order of how they are input into the join call. But then it's going to just put NAs where there's not a match between the two, but it's going to retain all of the rows. Okay, there's also a pivot, and this is kind of the last thing we're going to cover in this. I know there's a lot here, but hopefully the hands-on will help kind of cement these ideas together. So pivots are a way that you can take a data frame and change the structure so that it's longer or wider. This is useful if we want to stack data prior to doing some sort of plotting. If you have data that's coming in SDTM format, you can do pivots to make it closer to a non-mem style data set. They're commonly used when you're building your data sets. And these replace gather and spread, which were previously used syntax in R, and these are now what is recommended. I will answer this question during the break. Okay, so pivot wider. We want to, so I'm including the code in the arrow because this will come up in the hands-ons. So we want to pivot, so we're specifying the ID column. We keep the ID column. We want to take the names for the new column from the name column and the values for the new columns from the value column. So what's happening here is we're taking this long data set and pivoting it wider so that sex, age, and weight are now columns, and the values associated with the ID are included as rows. We can go the opposite direction as well using pivot longer. So we have this wide style. If we pivot it longer, we can say we want the columns from sex to weight, and it will treat everything else as an ID column. The names go to a column named name, the values go to a column named value. So this is how you kind of go back and forth between these structures. This slide is on character manipulation. I'm going to just leave that for now. You can read through it. You can ask me questions about it. This is how you work with characters. But now we're going to go into the next hands-on. So we're going to modify a data set. So in the email that I sent out, there was a CSV file called mad_nonmem.csv. So your first task will be to import that data set. You're going to filter, you're going to mutate, you're going to drop some columns, you're going to move columns around. And then if you finish all that and you want to keep playing, little challenge is to use pivot to change the structure of that data set. So you're at 135. We're doing okay. So we're going to go to 155. We're going to take 20 minutes right now to do this. Okay. So at 150, I'm going to come up and tell you how I did it. And then we're going to have a break for a little bit so people can get some coffee, and then we'll go into more. So yeah, we'll be circulating to help out. People are encountering the same issues here. So you're not alone if you're frustrated and you didn't even get to step 2. That's fine. We're doing great. We will look at how I did it. I'm gonna just pull up our studio and show you guys. So share this screen. Here's my RStudio. Don't save. Here is my hands-on 2 solution. Okay. So at the top, you need to use library. If you did not put library tidyverse at the top of your script, you cannot use any of the functions that we just talked about. Library tidyverse. First line. So I'm inputting my code into an R script at the top here. When I hit Command Enter, it will run that line of code and move the cursor to the next line. So I just ran that. The console output shows me that I ran this line, library tidyverse. It attached all of these packages. It tells me what version of the packages. If there's a shared name between functions in packages that were loaded, it will tell me what those were. And that's all that I've done so far. You can import multiple libraries. So what I had in my solution initially was loading the individual packages that are used in this script. That's good practice to do, but it's very easy. You don't need to have all of these scripts. You can just say library tidyverse and it will load all of those scripts in for you. Okay. Next, I'm going to set my working directory. Remember, your working directory is where R is going to look for stuff. So I have my Google Drive here, and I saved my output there. So I'm going to set my working directory to that. If I go to the console and I type in get working directory function, it returns a long string with all of my information, but it says it's in the IUCTSI Workshop 2024 folder that I created in Google Drive. Now I'm going to import the data. Now, I said if you use library, it's going to import the functions. Another way that you can access functions inside a R package is using these 2 colon operators. So in the read R package, I want to use the read CSV function. So this is an alternate way to specify what function you want to use if it's inside a package. So I want to read that data set, which is located in my working directory. I'm going to use the assign operator and assign it to a variable named dat. You can now see on the right-hand side of my screen in this environment pane, I have loaded an object called dat that has over 1,000 observations and 25 columns. You can click the little arrow and it'll show you information about that if you want. What I like to do when I import a data set is use the head function. Head will print the top 6 lines of your data set. So if I run that to the console, it's going to show me my column names at the top, the data type within each of the columns, and then the contents of the first 6 rows. If you used the RStudio GUI to import your data set, it probably didn't work, and that's why you're not able to access column C, because it didn't know that the header was actually the names that you wanted to assign. So that is why I would recommend using this function and not using the GUI. It's also a reproducibility issue. If you're doing anything in the GUI, it is not being captured to be reproduced later on. And everything that you want to do in R, you can do in an R script and write it out and have it do for you. So if you did not get the data imported, copy this line, assuming that the file is in your working directory. If you don't have your working directory set, you can also just directly in here, the call to read CSV, you can just have the long line of where it's located, not just the file name. Just put the path to the file on your system in front of it, and it will import it that way. Okay, that's how we get the data in, and now we can do stuff with it. So I asked you to comment out the C. I didn't ask, can everybody see the code here? Good size? Yeah, cool, okay, keep going. So I asked you to filter out all of the column or all of the rows where C is equal to the letter C. So if we run this function called count from the dplyr library, we can see there are 1,000 lines where it's a period. There's about 50 lines where it is a C. So 50 or 48 of my lines will be filtered out if I do this. I'm fine with that. I can look at my data and see where it is. This is just, thinking about making checks as you're going through and writing your code. What assumptions are you making? I assume there's less than half of the data are commented out. So I'm going to check that. I'm going to just print it. Looks good. Let's go to the next one. Okay. So you'll recall when I imported the data, I stored it in this object dat. Something that I like to do if I am making changes to an object in R, I like to save it to a new object. Why do I do that? Because if it looks funny because I messed something up and you just overwrite the existing one, then you got to kind of go back to the top and regenerate the object again. But if you save it to a new variable, then you still have access to the old version and the new version. You can look, make sure that it worked. So what I'm doing here is doing all of these steps applied to dat, and I'm assigning it to dat_filt. So the first thing that I asked you to do was to filter out all rows where in the column C, where the value is equal to C. So the column name here is on the left. You do not need to put the column name into quotes here. You do not want to put the column name in quotes here. We're saying not equal to, and the value is C. We're putting C in quotes because it's a character. And because if we said C is not equal to C, then it's going to look for an object named C in your environment or in the columns, and it's not going to like it. So thinking about building these conditional statements with column on the left-hand side, whatever you want to do, not equal to, greater than, whatever. And then on the right-hand side, it needs to be what the value is in the data type that it's comparing. Okay, the next step was to create a couple new columns. So we're using the mutate function. You can create multiple columns by having them separated by commas. I like to put each new variable on a separate line. So time D, we're converting time, which is in hours, to time in days. So I'm going to divide time by 24. And we're going to use the round operator. I didn't tell you about round yet, but I'm using it. And so here's an introduction. You don't need to use it. Round is going to round to the nearest hundredth. So I want 2 decimal points. So that's the second argument in round. That output of that is going to be saved into time D, time days. Now sex_C, I'm using _C here to tell me that it is a character type. And the next one, I'm using _F to tell me that it's a factor type. You don't need to do that. That's just something I like to do so I can easily look at a column name and know what type it is if it's different from how it was imported. So I'm using if else here. So we're saying all of the sex equals 0 values are being assigned M for male. All of the sex equal 1 are being assigned F for female. That's what this if else is doing. And then we are creating a factor for dose. So we want to take the dose column. We're going to convert it into a factor using this factor function. And then the levels for dose, you can manually type it in. These are the different dose levels that are included in the data set. You can check that by just saying dat distinct dose. And that tells me 0.5, 2.5, 10, and 25. So then you can either type that out like I did here, or you could save that as a variable and pull it in. I could say dose levels saved. I look at the dose levels object vector with 3 values. Actually, it's a data frame. We don't want it to be a data frame. So I'm going to use the pull function. That's going to typecast it to a vector. So now we can see it is a vector of 4 values, 0.5, 2.5, 10, 25. So now if I want to specify my levels, I can just do dose levels, and it will look for that variable that already exists in the environment and pull them from there. So that's a way where you can automate this sort of thing and not type in hard code is what it's called, all of the distinct values. And this makes your code more flexible. If you import a new data set, but you want to do the same operations, but it has different dose levels, doing it this way will allow you to not have to change your code. It will just work, which is nice. Okay. Now I wanted you to drop some columns. So if you use the minus, so you could list minus TAD, minus whatever's after TAD. I said all of the ones between TAD and ADDL. So I'm using the minus here and then the C function. So everything in there I want to drop. And then dose time I also want to drop, but I did not do that correctly, did I? There. So remove all of those columns using that minus operator for select. And then finally, the last thing was to move the time D column over to after time. And so that's using this relocate. This new column that we created is automatically added on to the end. When we relocate, it will move it over to time. So when we run that, we can then print our dat filt. So now we can see we've dropped some rows. We can see up here, dat used to have 1056, and now we're down to 1008. So we've dropped all of the C rows. We have created some new columns and dropped some columns. We have a different number of columns here, 16 versus 25. And we've moved the time D new column that we created so that it is next to time. You'll notice that I'm doing all of these sequentially in the same pipeline. And this is kind of a nice way to string together different steps so you don't have to save your intermediate output for each point. So that is how I accomplished the challenge today, or the hands-on. So I'm going to stop and not go through the challenge because I think it's probably a good time for us to take a break. So let me just verify. Hands on. Yeah, okay. So yeah, we're gonna take a break right now. Let's do that. Let's do 10 minutes. Good? Yeah. If you have questions, happy to answer them during the break time. Get some coffee, water, whatever you need to do, and then we'll go back up. Pardon? There's a chat question, Q&A. I think they've all been answered. Oh, no, open. I'm lying. Could you comment on the advantages and disadvantages of pivot long and melt function for reshaping data frame? Yeah, briefly, pivot longer and pivot wider are new versions of the melt gather spread. That's kind of the old way that you would do these types of pivots. So the reason for using the new functionality with pivot longer, pivot wider is that it's kind of the way that Tidyverse wants you to do these types of transformations moving forward. So those old functions will be disappearing at some point. They do an okay job of like keeping legacy functions around for a while, but at some point they disappear. So I would recommend if you know how to do melt or gather spread, you can pretty easily learn how to do the pivot if you just take time and read through documentation, figure out how those arguments are mapped to each other. Yeah. Okay, so let's reconvene at 2:20. Thank you.